Think about how space technologies can influence our everyday dining table. Imagine that satellite data and NASA research have already been helping to improve sustainable agriculture methods for several years, working in partnership with organizations like the FAO and the NASA Harvest Food Security Consortium. These collaborations enable farmers to better cope with the challenges of time, resource shortages, and climate change. NASA's capabilities in monitoring the Earth from space provide farmers with unique tools to understand the condition of their fields. And technologies developed for growing food in space are also being applied here on Earth. The NASA Harvest Consortium is advancing methods that help us better cope with climate change and natural disasters. Satellites and experimental environmental control systems are already bearing fruit on farms today. For example, the harmonious combination of satellite imagery and modern hydroponic solutions makes it possible to grow crops even in seemingly unsuitable conditions. This is not fiction, but real cutting-edge science that is already being applied and delivering tangible results. What lies ahead for us? These are not just experiments for the sake of curiosity. This is the systematic development of technologies that are taking agriculture to a new level of adaptation and resilience. And the most fascinating part is that we are only on the threshold of even more revolutionary discoveries that will undoubtedly lead to the transformation of agriculture and our future. Imagine how technologies originally designed for interplanetary exploration are now actively helping us here on Earth. From the very beginning of its history, NASA has worked on programs that, alongside the exploration of the Moon and Mars, have also studied our own planet. One of these significant achievements was the introduction of satellite remote sensing of the Earth. These specialized satellites, developed in parallel with space programs, have been helping us unravel the mysteries of the Earth from the very beginning. For example, spectrometers developed for interplanetary missions, which were originally intended to identify the composition of other planets' atmospheres, are now used to monitor methane leaks on Earth. This is not just a matter of scientific interest, it is real assistance in reducing environmental problems. Thanks to fruitful cooperation between the space and agricultural sectors, farmers have gained the ability to monitor the condition of their fields in real time, assess soil moisture, manage water resources, and prevent plant diseases. This is especially important for countries in North America and Africa, where satellite monitoring data has been actively used for several years to increase agricultural efficiency. With these powerful tools, which NASA developed with both space and terrestrial needs in mind, technologies that seemed destined for the skies have become a reliable support here on Earth. The next stage in this exciting journey is the start of real-world experiments that will inspire further steps toward future-oriented developments. At the beginning of its work on agricultural methods, NASA set out to create systems that could provide astronauts with fresh produce in space conditions. These efforts led to a program known as CLSS, Closed Ecological Life Support Systems. Systems like the famous veggie on the ISS have demonstrated in practice how hydroponics allows greens to be grown without soil and with minimal water use. Hydroponics became NASA's first major area of research, as it was ideally suited not only for space missions but also for arid regions on Earth. Thanks to this method, scientists discovered a new world of possibilities, enabling increased crop yields and reduced consumption of valuable resources. This became possible due to close collaboration with biologists and agricultural specialists who helped adapt these developments for use on Earth. These pilot initiatives were not just successful experiments, but an important step in the technological advancement of agriculture. NASA demonstrated how advanced space technologies can have a tremendous impact on solving problems here on Earth. Incredible interdisciplinary collaboration made it possible to gain a deep understanding of biological processes and provide technological support for these discoveries. Nevertheless, despite their enormous potential, many of these developments were only prototypes and required further refinement. But the real magic lies in the fact that it was precisely these first steps that inspired numerous commercial and research projects, initiating long-awaited changes in agriculture. And all of this is just the beginning of a journey toward new discoveries that could further transform our understanding of agriculture in the future. In a world where space technologies are becoming an integral part of our daily lives, NASA's Earth Observing System programs demonstrate their significant contribution to agriculture. These Earth observation satellites help farmers predict natural disasters such as droughts and floods. This gives farmers the opportunity to plan their planting in advance, minimizing losses and increasing yields. Automated climate control systems in greenhouses, inspired by life support technologies on space stations, are one example of such implementation. These systems are being developed by NASA as well as other institutions, including Russian universities, demonstrating a joint global commitment to sustainable agriculture. Microclimate control in greenhouses makes it possible to increase yields and expand the range of crops grown, creating conditions for the development of agriculture in any climate zone. Soil analysis technologies were also inspired by space instruments. The characteristics of sensors used in research missions on other planets have stimulated the creation of instruments capable of accurately assessing soil composition on Earth. Such sensors help optimize fertilizer use and reduce environmental damage. As these advanced technologies continue to evolve, it is important to understand that their adaptation requires unique solutions tailored to Earth's needs. The knowledge gained through space science provides a powerful impetus for agricultural innovation, helping us make farming more sustainable and efficient. These achievements in space engineering are being transformed into an integrated system of advanced solutions that promise to change the future of agriculture for many years to come. Behind the scenes of implementing space technologies in agriculture stand not only individual scientists but entire teams who have joined forces to achieve grand goals. One such example is NASA's collaboration with universities and companies like Crop One Holdings, as well as research teams from the University of Utah and California. These teams are developing projects aimed at ensuring food security amid rapid population growth. Among the names that have left a significant mark on this project, true leaders stand out, such as Bill Knott and Tom Dreschel. They led research on the development and implementation of vertical farms and microclimate control systems. Together with other teams of scientists, they created closed ecological systems on Earth based on principles used in microgravity conditions. Special attention is given to the technology of creating a digital twin in agriculture. With this method, NASA enables farmers to accurately assess crop conditions using satellite data. This makes it possible to accurately forecast yields and monitor plant health, which is becoming an indispensable tool in modern farm management technologies. The development of hydroponic systems, nutrient films, and closed ecosystems plays a key role in ensuring the sustainability of agricultural processes. Together with digital monitoring technologies, these solutions open up new horizons for the efficient use of resources. Large-scale collective research and development continue to make an invaluable contribution to our shared food security. For now, it remains to be seen how these efforts are coming together to achieve practical results here on Earth. After all, it is precisely these efforts that can dramatically change our approach to agrotechnology and ensure a stable future for the entire world. Innovations and technologies inspired by NASA's space experiments have truly revolutionized agriculture on Earth. The main focus here is on the concept of closed plant cultivation systems, aimed at creating optimized conditions for growth. The foundation for such solutions was laid by experiments on growing plants in space, which require a precise monitoring system to control the microclimate. These smart microclimate control systems are now being developed by other research centers and commercial companies and have become the foundation for modern vertical farms and artificially controlled environments. They automatically regulate temperature, humidity, and lighting, providing the necessary conditions for various crops. This not only increases crop yields, but also reduces water and other resource consumption, significantly boosting agricultural efficiency. In practice, air recycling and organic waste processing technologies developed for closed space systems are already being partially applied on Earth. Although their use in everyday commerce is still limited, the potential is enormous and development continues. As for photosynthesis, there have been no significant changes to the process itself, but parameters to improve photosynthetic efficiency have indeed been refined. NASA is studying how improved microclimate conditions can affect photosynthetic activity, making such agriculture even more productive. These innovations represent an integration of natural ecosystems and technological solutions. It is precisely this combination that makes it possible to create more sustainable and productive agricultural systems, which is especially important in light of future challenges related to population growth and climate change. And ahead of us lie even more amazing discoveries that will change our understanding of how food can be grown for every person on the planet. The use of space technologies in agriculture has already proven its effectiveness, and today they are used all over the world. Satellites such as Sentinel and Landsat, along with commercial solutions, are helping farmers across the globe. With their help, it is possible to comprehensively monitor the condition of soil and vegetation, especially in arid regions where the issue of efficient water use is most acute. Satellite imagery and data analysis make it possible to optimally plan irrigation, which saves water and increases yields. Inspired by space programs, vertical farms and closed-loop life support systems are beginning to operate in harsh climatic conditions. Such technologies are helping in Canada and Norway, where year-round cultivation is impossible due to low temperatures and harsh climates. These solutions are being developed by commercial and research projects, and the influence of space is evident in the adaptation of technologies and approaches. In Southeast Asia and other regions where natural disasters are inevitable, the automation of greenhouses and microclimate management becomes a lifeline. Based on sensors and modern systems, such complexes make it possible to stabilize yields and protect them from weather-related risks. This is an example of the interaction between satellite monitoring and modern control and management technologies. Looking at successful examples, it becomes clear that space and agriculture go hand in hand, forming a synergy that promises to open up new horizons. With the development of satellite technologies, artificial intelligence, monitoring, and automation, the agricultural sector is undergoing a true revolution. And although we are only at the beginning of this journey, we can already see how our connection with space is paving the way toward a bright agricultural future. Riding the wave of modern innovations, NASA, in partnership with various international organizations, is creating cutting-edge technologies that are truly inspiring. Undoubtedly, remote sensing data of the Earth utilizing satellite systems make a tremendous contribution to global food security, especially in countries with developing agriculture. These technologies help assess crop conditions in real time and predict adverse climatic conditions. In the far east of Australia, in cooperation with local institutions, space data is being used to improve agro-monitoring. With their help, farmers can better plan water resource management. Although such technologies are still in the active testing phase, they show significant potential for improving crop yields in arid regions. In California, farmers are actively using satellite technologies to manage limited water resources, which is especially relevant in the face of ongoing droughts. NASA pilot projects, such as the creation of digital twins of agricultural lands, help optimize agricultural production and offer hope for long-term success. Bringing remarkable prospects to the global stage in a number of countries in Africa and Eastern Europe, international initiatives are applying satellite data in agriculture. These projects are often interdisciplinary, bringing together NASA, United Nations agencies, and other scientific communities, which makes it possible to improve the productivity of the agricultural sector. This approach demonstrates that the integration of space and terrestrial technologies, even at the research stage, opens up opportunities for a sustainable future. NASA's technologies truly promise to bring about an agricultural revolution. And although this is only the beginning of a long journey, the potential for breakthrough changes in agricultural practices is already evident. We look forward to seeing how these monitoring systems will usher in a new era of productivity in the agricultural sector in the future. Farmers around the world are experiencing a significant surge in efficiency thanks to space technologies. Satellite monitoring, for example, provides data on vegetation and soil conditions, which, when combined with AI models and ground measurements, help accurately determine moisture content and nutrient deficiencies. The Sentinel and Landsat systems, developed in collaboration with NASA and the European Commission, have significantly improved the effectiveness of such methods. They help farmers optimize irrigation and fertilizer application processes, saving resources. What's even more remarkable is how variable rate application (VRA) has made targeted fertilization easier, with rates calculated using satellite imagery. This allows farmers to act more precisely and responsibly, reducing both costs and environmental impact. Space-based data exchange technologies are integrated into new agrotechnical developments, supporting the evolution of agriculture. Automated greenhouses are another example of how such innovations are being used. Although specific management systems are developed by agrotechnical companies, they rely on NASA data and other sources for a comprehensive approach to climate monitoring. This approach makes it possible to significantly increase the number of crop cycles per year, offering farmers new paths to profitability. Vertical farms using hydroponics and LED lighting in limited spaces have also benefited from space-based analytical systems, which is already evident in urban areas. Although these technologies are not directly related to space, their development is inspired by the resilience and autonomy inherent in space missions. In addition, satellite data helps detect the spread of pests and plant diseases, preventing crop losses of up to 30%. This demonstrates how technologies originally aimed at space turn out to be highly beneficial for the development of agriculture on Earth. The next stage is not just about easing current difficulties for farmers, but also about active collaboration between countries such as the United States, Israel, and the European Union to strengthen food security worldwide. Space technologies are no longer just advanced tools, they are becoming a powerful means of protection against global challenges. Imagine a future where space technologies are actively preserving our planet, even when it comes to something as simple as the potato on your lunch menu. Satellite remote sensing is already being actively used to optimize the use of water and fertilizers, thereby reducing water pollution and managing land resources in a balanced way. Such monitoring makes it possible to forecast and efficiently allocate resources, a practice also supported by the UN and the World Meteorological Organization. Although space technologies do not directly restore depleted soils, they provide vital data for optimizing land use and preventing ecosystem degradation. This provides a foundation for more sustainable agronomic practices, which can have a significant impact on biodiversity when combined with conservation measures and agricultural technology. Microclimate management in greenhouses and vertical farms has been adapted from space life support system developments. Such systems use energy-efficient approaches, which help reduce the carbon footprint by lowering energy and resource consumption. Although they do not directly reduce emissions, their efficiency leads to significant indirect reductions. The use of renewable energy sources and precision agriculture, based on data from space, opens up the possibility of creating closed-loop ecosystems that operate reliably in urban environments or harsh climates. As a result, agriculture contributes less to climate change and becomes more sustainable. These achievements demonstrate just how powerful a catalyst space technologies can be for the upcoming agricultural revolution. With their help, we are rapidly moving toward harmony between production and nature, where efficiency and conscious stewardship become the foundation of sustainable planning for the use of food and natural resources. The introduction of space technologies into agriculture has opened the door to a revolution, but it also faces considerable challenges. One of the most well-known barriers is the need for investment, which can deter small farmers. However, contrary to expectations, access to high-quality data does not always require significant expenses. Satellite images with a resolution from 10 to 30 meters are often provided for free, giving farmers the opportunity to use advanced data without additional costs. Nevertheless, integrating such technologies requires not only devices but also skills. Analyzing satellite data, processing it, and using AI tools for field diagnostics all require time and training. Here, improving digital literacy is essential. Farmers will need to master modern IT technologies related to web services and data analysis. Infrastructure limitations remain another challenge. Not all regions have access to stable internet connections, which is critical for working with high-tech systems. At the same time, low-orbit satellite systems such as Viasat are helping to bridge this gap, gradually improving the situation in remote areas. The cultural aspect also remains important. Traditional methods, which are deeply rooted in rural communities, sometimes hinder the adoption of new technologies. The transition requires not only technical readiness, but also the courage of farmers to change centuries-old practices. Support from government and international initiatives also remains important, such as programs aimed at reducing the economic gap, assisting small businesses, and developing regulatory frameworks. This comprehensive approach, combined with the availability of technology, suggests that potential barriers can be overcome. And this is just a step toward a future where the agricultural sector will be able to fully realize the potential of space technologies and ensure food security. On the threshold of a new agricultural era, reality is becoming even more exciting. Modern satellite technologies infused with the power of artificial intelligence and machine learning are already providing incredible accuracy and speed in field monitoring. These innovations make it possible to literally track crop conditions in real time, forecast yields, and even manage irrigation, minimizing labor and resource costs. However, this is only the beginning. Integrated satellite-based systems do much more. They not only forecast, but also actively control agricultural processes, from irrigation management to the operation of automated farms. Such a symbiosis of technologies is transforming agriculture, reducing costs and increasing its sustainability. As for biodiversity, it indirectly benefits from these innovations. Accurate assessment of soil and plant conditions helps operators make informed decisions that reduce risks. But it is important to remember, managing biodiversity is a complex task and also requires agronomic solutions. In cities, the influence of space on agriculture is only just beginning. The concept of smart farming, which includes the Internet of Things, robotics, and artificial intelligence, is already taking shape. Although the implementation of satellite technologies here is still in its early stages, their potential is enormous and is confirmed by the rapid development of agrotechnologies. These achievements are not just methods of observation, but entire technological ecosystems for managing agricultural production in real time. Modern space programs, whether from the European Space Agency, NASA, or private startups, are joining forces to create tools for designing the future of agriculture. Thanks to international cooperation and a shared drive forward, space technologies are becoming a reliable foundation capable of paving the way towards sustainable and productive agriculture in the future. This fascinating journey was only just beginning, and its possibilities promise to be limitless.